Good morning, everyone. Welcome to day three, where we're going to take a look at what's in air and also hopefully explains the differences between atoms and molecules. You want to have your bill for today's lesson. We are going to take quite a few notes, but shouldn't take that long. And then you have a form that you need to complete that is listed also under classwork in this classroom. Hopefully before you got into this presentation, you took a look at the presentation that I put together there. It's demonstrated right over here in this picture here where we burn some ethanol on a balance, just to make sure you understand that, yeah, we can use that as an instrument to measure how matter can move. We had quite a few good answers out there. We had some really different thinkings in terms of how matter moves. And some people may have confused a little bit of energy in that as well, but we responded to a lot of those comments. If you received a comment from Mrs. Brown, probably you need to explain a little bit deeper into what you're trying to say. We cannot accept one-word answers, so make sure you explain. If we post a question, that you explain what you're thinking. Couple shout outs. Shout outs go out today to Layla George and Attica Paris. These two students did an outstanding job in explaining how matter moves when ethanol burns. I think both students used volume to answer that question and mentioned how you could measure the volume of the ethanol before and after it's burned. Great job. All right, let's get into air. One of the questions that we often ask students is, does air have mass? Is this mason jar over here empty or is it full? If you think about space and space is a vacuum, I think most of us would know that there is something in this, but we don't quite know because it's hard to see. So let's talk a little bit about how we do zoom into this and what we should look at. When we look at air, this presentation is going to use clouds, and clouds are obviously very big and filled with a little bit of water and stuff that, is given off by all sorts of things that are on our planet. Could be pollution from cars. It could be things that we breathe out. Who knows what, but we know that air is pretty much, around us in all sorts of capacities. And this would be a large scale view. If we zoom in, we can zoom in a little bit closer and we can get into what is called the macroscopic view, which is we're zooming basically into a droplet of water. And we're going to go even a little deeper here into that droplet of water and the edge of this. So we're going to look at the edge of the droplet of water and sort of the molecules that are here and there. But again, droplet of water, macroscopic level. Microscopic level, we see that edge right here. This is the edge of the water and then the air. I'm going to go a little bit closer. Now we're right at the edge of the water and we're in the air. And you can start to see now, we start to see these like ball and stick figures. We call those in chemistry. And so we're going to take a look at what these different things are. I'm going to zoom in a little bit closer and we can see that the one is a water molecule. So, the water molecule is going to be this one right here. And that's what they're going to zoom in on that picture there. And you can see that. All right, there are different kinds of molecules in air. We have oxygen molecules and water molecules and carbon dioxide and nitrogen. So a lot of different molecules are in air. So let's take a look at that. So our air, if you take a look at this pie chart here, is about 78% nitrogen. A lot of people don't know this, but really nitrogen is what is called an inert gas. It doesn't really react with our bodies, and it's in the air. There are some plants that can take it in. A lot of farmers I know will be planting soybeans, and if you have soybeans that are planted around your house, those plants actually can absorb nitrogen through their roots, and they use those to build molecules in their own in that organism, a soybean plant. Oxygen you can see is 21%, so a significant amount, not as much as nitrogen, but a pretty good amount. And then we have some other things here. Notice we have argon. A lot of people don't realize, but yeah, it's a small amount, less than 1% is in our air. And carbon dioxide, which is talked about in the news all the time, people think that our atmosphere is filled with carbon dioxide. It actually is only 0.03%. And water is also in there, and that varies depending on where you're at. Obviously, if it's a humid day, you got a lot of water in the air, but if it's not, you're going to have very little. One of the things tasks that you have is to differentiate between an atom and a molecule. And this picture right here shows kind of helps with that. So if we look at the very first picture here, it just says the word oxygen, but notice that it only has one oxygen atom. So this particular picture here is just an atom. And if we look at number 5, it says oxygen also, but notice that that is 2 oxygen atoms, and they're connected by what are called bonds. And you can see that this would be not an atom, but instead this entire thing is a molecule. So we have single atoms and we have molecules. Go ahead and pause the video, look at these particular things. Can you identify which of these are atoms, which boxes are atoms, and which atoms are molecules? So take a minute and look at those. You can pause if you want. Okay, great. So hopefully you had a chance to look at these different boxes and you can tell which is which based on what we just talked about. If we go back in the presentation here, we can see that oxygen, in terms of our air, it's a molecule. It's not just a single atom. It is 2 atoms together, but it is a molecule. Atoms and molecules in air. Oxygen molecules are made of 2 oxygen atoms. Okay, makes sense. These are things that you could jot down in your notes if you wanted to, just to make sure that you have this information available in case you need it. Nitrogen molecules, N2, are made of 2 nitrogen atoms. And water molecules are made of 2 hydrogen and 1 oxygen atom. A lot of us already know that. If you've had chemistry this year, this stuff is probably mostly review for you, but you still may, a lot of people don't know which molecules are actually in our atmosphere. And then carbon dioxide is CO2, and that's made of 1 carbon atom and 2 oxygen atoms. And so we are ready to go then into the next thing about atoms. This is a big concept that you do need to have in your bill or on a piece of paper, is to make sure you understand the facts about atoms. Atoms, which are single elements in most cases, like I've showed you before in some of those other slides, atoms last forever unless there's a nuclear change. Now, in most cases, nuclear events aren't common, okay, in terms of like an incident like that could occur, and like for example, Chernobyl, or any sort of nuclear reaction where they're changing or altering things. Those are not natural events. So typically atoms are going to last forever no matter what. They're not going to go through many changes. So that's number 1. Make sure you know that. Number 2, atoms make up the mass of all materials. So anything that has mass is going to have atoms. So make sure you understand, if I have anything in my hand, if I take this pen right here and hold it in front of the screen, and you can see it, this pen is a material and is made of atoms. The third thing is atoms are bonded to other atoms and molecules, which is kind of shown in those previous slides when we looked at those boxes, that you must know that, if I'm talking about a molecule, I have to have more than 1 atom. So that concludes this presentation. And so what you can do then is there is a form that you're going to need to fill out for today to answer the questions about air. Pretty simple. If you have any questions, always feel free to email or post something in the class comments. Thanks for watching. See you on Thursday.